The 100 kilogram block in the figure takes 6 seconds to reach the floor after being released from rest. What is the mass of the block on the left? The pulley is massless and frictionless. And I think the first sentence here is a complete kinematic sentence. Okay, so we have the time to reach the floor, and also from this picture here, we know the displacement here is 1 meter. And we have time and displacement here. So we can use this formula. Y is equal to the initial velocity multiplied by t plus 1/2 multiplied by the acceleration multiplied by t squared. I think we have all of the variables except for the acceleration. Okay. Now, let's see here. The displacement is 1 meter. And then the initial velocity, we have it is released from rest. So that will be 0. And then t is 6 seconds. So I'll have 6 here. And then plus 1/2 multiplied by the acceleration multiplied by t. T is 6. So I'll have 6. And then square. Right, and on the left hand side I will have 1, and on the right hand side I will have 0 plus 6 squared, that will be 36. 36 divided by 2, I will have 18. 18a, or 1 is equal to 18a, therefore a is 1/18. And the unit here will be meter over square second. Good. Okay, now let's see the first mesh here. Let's draw the free body diagram at this block here. So here we have the weight of this 100 kilogram. Let's name this as weight number 1, pushing this block down. However, we have the tension of the rope pulling this up. So I will have T here. And remember, the direction of movements here is going down, right? It takes 6 seconds to reach the floor. So initially it's here, and then it will reach the floor. So the direction of the movements is downward, and the direction of the movements here is the positive one. I want the forces that goes with this direction as positive. Okay, now let's apply Newton's second law to this block here. So I will have sigma F, the net force, is equal to the mass times acceleration. Okay, so we have the weight here pulling this down. So I'll have weight of 1. And then T here to the opposite direction. So I'll have minus T. And that will equal to mass number 1 multiplied by the acceleration. But weight number 1 here is m1 multiplied by g, and so I will have minus t, and that will equal to m1 multiplied by a. Or we can isolate for t here, the only unknown here. So I'll have d is equal to m1 g minus m1 a. Good, and I think we can plug all the numerical values. So I'll have T is equal to 100 kilogram multiplied by G, which is 9.8, and then minus 100, and then the acceleration is 1/18. Good, and we have the tension of the rope, which is 100 times 9.8, and then minus 100 multiplied by 1/18. And that will be this one here, 974.44. 974.44. And the unit here will be in Newton. But the question is asking us about this mesh here. So we need to do free body diagram on this mesh too. And it's pulled down by its weight, of course. Let's name this as weight number 2. And then it's pulled up by this rope. Okay, and it is still the same rope, right? So the tension will be the same. So I will have T here, and the pulley is massless and frictionless, so we ignore it. So T is going upward in this case. However, here the direction of movements is to the opposite direction, right? Because this is going down, this is obviously going up, right? And I can apply Newton's second law to this smaller block. Okay, so I will have sigma F is equal to the mass times acceleration once again. And for this one, the positive one is T because the direction of movements is going up. So I will have T here, and then it is opposed by this weight number 2. So I have weight number 2, and that will equal to the mass times acceleration. Okay, so we'll have T minus weight number 2, that will be mg, and that will equal to the mass times acceleration. We are looking for a mass, so let's put all the mass on the one side. So I have T is equal to ma plus mg. We can factor out this m, so I have T is equal to m multiplied by a plus g, and then we can get this m here. M is equal to T divided by a plus g. Okay, so now we can plug in the numerical values. T is this one, 974.44, and then the acceleration here is 1/18, and then g here is 9.8. And let's plug that into calculator. So we will have 974.44 divided by 1/18, and then plus 9.8. And I will have 98.87. 98.87. And the unit here will be in kilogram. So we have this as the mass of the lab. Okay, so I think the picture here is kind of misleading because that is much larger than this. Oh, maybe it's different materials, but yeah, okay. So we have 98.87 kilogram as the mass on the left, and it is makes sense because it goes down, right? And it has to be lighter than this. This has to be heavier. Okay, I think that's all for this problem. Do not forget to like the video, subscribe to the channel, and thank you for watching. See you in the next video. Bye bye.